Alright friends, hi there, my name is Max Wolf. I'm TA for CS61A in spring 2015, and today I'm going to do a walkthrough for quiz 2. Okay, so I've pulled up the quiz 2 directions, downloaded this quiz2.zip, unpacked it. Okay, great, so I've got an OK file, this quiz 2 OK in Python file, so I'll put it up in Sublime. Okay, there we go. I'm going to have both the directions open and my quiz open while I go through these directions. So we'll take a look at what it's asking me to do. So let's read the directions. Okay, don't cheat. Use OK. That's how you test with OK. Great. Okay, so now we get to our first question. Is implement make change, which takes a positive integer amount and a dictionary of coins. The coins dictionary keys are positive integer denominations and its values are positive integer coin counts. Okay, so it looks like we have some sort of like piggy bank, right? So pennies, in this case we have 4 pennies and we have 5 nickels, right? Which is what it says right here. I'm sorry, 2 nickels. The make change function returns a list of coins that sum to amount. We pass an amount as an argument here, okay? With the count of any denomination k in the return value is at most coins k. Alright, okay, so it looks like what that's saying is here, if I only have like one 2 value coin, then I can only have one 2 value coin returned, right? Here, you know, ideally I would make change for 4 with 4 pennies so that I could keep using the smallest denomination, but I only have 2 pennies. Alright, so I have 2 pennies and then 1 2 coin. Okay, that's cool. So if there are multiple ways to make change for amount, prefer to use as many of the smallest coin available and place the smallest coins first in the return list. Alright, so what I'm going to do today is I'm going to pretty much just go through this quiz as though I had never looked at it before, and you can get an idea of how a TA would approach starting this quiz, you know, straight from scratch. So the first thing I would do is what I'm doing right now. I've pulled up the quiz in Sublime and I'm looking at it at the same time that I'm looking at these questions, right? So I want to make sure that I don't lose sight of what the question is actually asking. Hopefully you would have done this sort of the day before the quizzes do. We tend to give 2 days for quizzes, right? So you have a day to look over stuff and let it percolate, and then a day to actually start writing code. Okay, I would also have been calm. You know, you have to remember that many people have solved this before you, and it would also be okay if you don't solve it. It's only a few points. So deep breaths. We're gonna start the quiz. Should be super fun. Oh, shout out as well to Samantha and Josh for encouraging me to do this and for walking through it with me in office hours. You guys rock. Okay, so make change. So this looks a lot like something that we had in homework 3 to me. So this looks like we're given some amount and we're given some set of coins, and we have to make change and return. Well, first off, we also have to return whether or not you can make change, right? So here we're not able to make change with we're not able to make change of a value of 4 with only 1 2 coin. So we're going to return none. So I think in homework 3, we had a similar problem called count change. And in count change, what we had was a you know, instead of having some list of coins that we could choose from, we had we sort of had some like biggest coin that we were allowed to choose from. In this case, every biggest coin had to be a power of 2, right? So we're returning the number of ways to make change for amount. But really, we just want to, you know, this is ultimately just going down the recursion and returning a 1 if it's successful and a 0 if it's not, and we're adding them up together. And so here I can sort of see, okay, wow, this looks like something that I want to use recursion on. It sort of seems to me like a natural recursive candidate, especially since we give you something called rest, right? So whenever you see something called rest, or you see something where, you know, it looks like we're starting to break the problem down a little bit. So we have sort of some big problem where we're trying to make change for 2, or we're trying to make change for 4. If it looks like you're able to break the problem down into some smaller variation of that same problem, in this case, if I have make change for 4 and I use 1 penny, and I'm making change for 3, and I have 1 fewer penny remaining, right? So you can sort of see that like this looks like a natural candidate for recursion, right? So whenever I see this rest, I think, okay, well, this looks like it's going to be a recursive candidate. Now, what I would do here is I would sort of take out a piece of paper and I would try to draw the recursion that I saw for the problem that was similar. which before was this homework 3. And what you'll see when you do homework 3 is that you really have two choices, right? Either, in this case, so I'll walk you quickly through my code here. So first things first, what I do is I create the largest power of 2 that you're allowed to use. And I have some helper function here because you're not given really enough information with just amount. You need to keep track of the coin that you're using. So when I had this count change question, it sort of says count change for return the number of ways to make change for some amount. You pass in an amount. You also want to keep track of a coin. So I added a coin variable, which is why I made a helper function. And then here what I do is I define my base cases. The base cases are if I'm out of coins to use, or I've overshot my amount, so I've been passed in some negative amount, then this is not a valid way to make change for this amount. Otherwise, if I've exactly nailed my amount, so I've been passed in the amount of 0, then I can return 1. You know, I've won. There's only one way to make change for a 0 amount. Then in my recursion, and you should draw this out, because it's a little hard to see just from looking at my computer. In my recursion, I either decide to use the biggest coin that I have, which in this case is coin minus, so I have some amount, right? And I have the largest coin. The coin is going to be some large power of 2. And I can decide to either use that coin, which is what I'm doing here. So I'm using that coin to help make change for amount, and I keep track of that coin. Or I just forget about the coin. I say, well, this coin might mess me up later. Mess me up in sort of there's ways that I'm able to make coins later, so I'm going to forget about it here. And I'm going to see how could I make change if I decided to not use that coin. So seems like a natural way to approach this problem, this make change problem. And here we're given the smallest coin, so we know what coin we want to use. It was already decided for us, given a starter code. Then the rest, that looks like the place that we're going to keep using our recursion. So let's first start by sort of defining our base cases, right? Alright, so before we had a base case that was sort of amount equals 0. So that makes sense, right? So if I'm passed in something that, you know, if amount equals 0, so if I'm passed in, I'm trying to make change for 0, an amount of 0, and that's pretty trivial, right? All I have to do is return some empty list. And the reason I'm returning an empty list instead of none or instead of something else is that I always have to return an empty list if I'm able to successfully make coins, right? So I'm calling an empty list a successful coin production. Okay, so that's why I'm returning an empty list there. So the other option, one of the other options is defined already. So if not coins, which means I'm out of coins and I have no more coins, I have this empty dictionary, then I'm going to return none. So it looks like remove coins is defined here. What does it do? It's going to copy a dictionary. It's going to remove a dictionary, the item from the dictionary. Or it's going to decrement the item from the dictionary. And then it's going to return the copy of that. Then change machine we'll forget about. Okay, cool. And so this is amount equals 0. Return an empty list. And then if we don't have any coins, then we're going to return none. We weren't able to. No amount that we have, we're able to make change for if we don't have coins, except for the amount 0, so that's okay. Okay, right, so amount 0, amount equals 0, return an empty list. If amount's less than 0, though, we want to return none, right? So if we're passing some nonsensical less than 0 amount, then, you know, that we can't make change for that. It's sort of nonsensical, we should just return a failure. And this will become important. It's important to cover all your base cases. This is an important base case if we accidentally overshoot. So say the amount that I get is 1 and I only have a coin that's of value 2, then I'm going to overshoot. because I have no valid ways to make change for the value 1, given that I only have a single 2 coin. Okay. And we'll print some stuff out, and that might make some sense. Okay. So here I've defined some base cases, and yeah, maybe it makes sense to test that it works for these base cases. So what I'm going to do is I'm going to take this, I'm going to go into my quiz 2 folder, which is in documents, sorry about this, spring, TA, CD, whoops, CD quiz 2. Alright, okay. So first things first, I might want to do Python OK. Oops. Make sure I have Python 3 installed. Max Wolf. Uh-oh. Now you'll know my email. Okay, so